Imagine you're about to flip a coin and are asked to call which way it will land. What options do you have? Well, heads or tails, right? But what if you never saw the coin? How would you even know which way it landed? Well, the answer is you don't. The entire time, your coin is in both the heads and tails state until you take off your hand and reveal the answer, with the result collapsing to one of the two options because you're able to measure your answer as you looked at the coin. This concept is known as superposition, and you might have heard a similar example of this thought experiment with a cat, a box, and some radioactive material. But since we like cats on this channel, we are going to skip the half-alive, half-dead feline and focus on coins. If we were to redo this thought experiment, this time leaving the coins as 1 for tails and 0 for heads, then we have just simulated the ability of qubits to be in superposition. But I'm getting ahead of myself. What are qubits and why are they even important? Well, you can think of qubits as the basis of our quantum computers. A classical computer contains bits that are in either states of 1 or 0. Everything from emails to videos are encoded in these binary digits. However, quantum computers use quantum bits, or qubits, as a quantum system that encodes 0 and 1 into distinguishable quantum states. Because they're able to take advantage of the rules of quantum mechanics, qubits are more powerful than a typical bit and can use principles like superposition and entanglement to their advantage. We had just explored superposition in our coin flipping example, but in real life, to get qubits into superposition, researchers manipulate them using precision lasers or microwave beams. The second principle of quantum computers, entanglement, allows two states of a qubit to exist in a single quantum state, so that when you change one state of a qubit, the other automatically changes, even if separated by long distances. Einstein labeled this phenomenon spooky action at a distance, since the mechanics of entanglement remains a mystery. However, it's because of entanglement that by adding more qubits to a system, there's an exponential increase in the productivity of a quantum computer. Now, if concepts like superposition and entanglement seem unusual and counterintuitive, that's because they are supposed to. Because these concepts are founded in quantum mechanics, which seeks to explain the behavior of particles at a very small level. Despite these advantages, though, there are still some downsides of relying on quantum computers. The interaction of qubits with their environments causes their quantum behavior to decay and ultimately disappear in a phenomenon called decoherence. This makes quantum computers way more error-prone than classical computers, with the slightest vibration or change in temperature causing qubits to fall out of superposition or entanglement before completing their job. These disruptions are known as noise, and researchers employ various methodologies to reduce it, like placing quantum computers in extensively protective environments. Still, many researchers are optimistic about the application of quantum computers to our daily world, such as in the simulation of molecular behavior to create new drugs, or to use optimization algorithms to develop efficient electrical batteries. So the next time someone asks you to call heads or tails, just say both, and know that your answer is the foundation for the future of technology and science.